In this reading session, we will be discussing the statistical methods in AI. So, statistical methods form the backbone of many AI techniques, enabling machines to process, analyze, and infer from data. So, descriptive statistics used to summarize and describe the main features, summarize and describe the main features of the data set. Okay. So mean median mode, within that we have mean median mode is a measure of central tendency. Then we have variance and standard deviation, a measures of spread or variability. Then skewness and kurtosis describes the shape of the distribution. Then correlation and covariance, it quantifies relationships between variables. Histogram and frequency, histogram and frequency distributions, they are visual representations of the data distributions. Then comes inferential statistics. It is used to make predictions or inferences about a population based on sample data. So within that comes hypothesis testing. T-test compare the means of two groups. ANOVA, analysis of variance, is compare means across multiple groups. Chi-square test independence between categorical variables. Z-test compare sample and population means. Confidence intervals estimate the range of a parameter with a certain level of confidence. Bayesian inference, update probabilities as evidence is accumulated. P-values, measure the significance of the results. Probability distributions is used to model and understand data distributions. Discrete distributions, Bernoulli distribution, which are binary outcomes. Binomial distribution, number of successes in a sequence of binary trials. Events occurring in a fixed interval, Poisson distribution. Now comes continuous distribution. So we have the normal distribution. So in discrete distribution, we have Poisson distribution, then binomial distribution, and Bernoulli distribution. In continuous, this is normal continuous distribution. We have normal distribution, bell curve, commonly assumed for many natural phenomena. Exponential, this is assumed, we must keep in mind. Exponential distribution, time until an event occurs. Uniform distribution, equal probability for all outcomes. Gamma and beta distribution used in Bayesian methods. Regression analysis, linear and nonlinear techniques to model relationships between variables. Linear and nonlinear techniques to model relationships between variables. So basically relationships. Linear regression models a linear relationship between independent and dependent variables. Linear relationships. Logistic regression used for binary classification problems. It is used for binary classification. Polynomial regression fits nonlinear relationships using higher order terms. Ridge and lasso regression regularization techniques to prevent overfitting. Generalized linear models extend linear regression to model non-normal response distributions. Extend linear regression to model non-normal response distribution. Then comes classification techniques. So next comes classification techniques, the statistical methods to assign categories to data. So naive Bayes probabilistic classifier assuming feature independence. Assuming feature independence. Discriminant analysis. Linear discriminant analysis finds linear boundaries. Quadratic discriminant analysis finds quadratic boundaries. K nearest neighbors classifies based on the Majority class of nearest neighbors. Now, clustering techniques. Unsupervised methods to group similar data points. Unsupervised methods to group similar data points. K means clustering partitions data into K clusters by minimizing variance within clusters. So K means clustering and K nearest neighbors. Hierarchical clustering builds a tree of clusters based on similarity. Gaussian mixture models, probabilistic clustering, assuming data is generated from multiple Gaussian distribution. DBSCAN density based clustering for arbitrary shapes. So that's it for this session. We'll continue in the next reading session.